Assalamualaikum warahmatullahi wabarakatuh. Today I want to share my answer in test 1 SKEE1073 session 2023-2024. So let's go. For the part equation, what is the primary function of a PN junction? So a PN junction is a one-way pathway that allows electric current to flow in one direction while blocking it in the opposite direction. So the current flow in one direction is forward bias, while blocking it in the opposite direction is reverse bias. Now, what is the significance of the Zener breakdown voltage in a Zener diode? Zener diode is designed to work in reverse bias direction without harming the diode. The function of Zener diode is to maintain a specific voltage across its terminal within given limit of line or load change. Now, the question number 3 is given the D1 is silicon and D2 is germanium. Determine the diode condition. So we can find the diode condition by using the voltage divider, because here we have a parallel D, right? Now we can find it by using voltage divider. So here the VD here we got 1 volt. So 1 volt is more than 0.7 volt for V silicon, so it is on. Now the 1 and 2 situation is the same R total, right? The third situation is different because it get a 5 ohm. So here we got 0.6 volt, which is less than 0.7 for V silicon. So the V silicon will be off. Okay. And the germanium diode will always be on because it is less than the VD we got. So for the part B, it is given the VS is adjustable 7.5 volt for minimum and 12.5 volt for maximum volt. Okay. Determine the load resistance RL when VS is equal to VS minimum. Okay. So when the VS is minimum, the VD is equal to 0, and the ID we got 1.5 milliampere. We got it from the IV characteristic here. Okay. This is the 1.5 milliampere when VS is minimum. So we using the KVL to get the RL. Okay. So this is the equation, and we got the RL is 3000 ohm. For the second, find a IDQ minimum and IDQ maximum. So we can find it by the KVL, just like a first one question. So here we got ID max is 2.328 milliampere and the ID minimum is 1.334 milliampere. Okay. Same just like this. This is wrong. This should be a minimum. Okay. Minimum. We got it from this. This is the VD maximum, and this is the VD minimum. Okay. This is my mistake. Here is minimum. Okay. Now the third question, explain what happened to the Q point if VS is reduced. So when VS is reduced below minimum value, the Q point will be reduced too, because the VS, when VS is reduced, the current will be reduced too, because V equal to IR. So the Q point will be reduced too. Okay. Now for the question number 2, from the figure B2, we can see this is the transformers, right? So here is a VP for primary voltage, primary, right? Now we want to find the voltage here and to find the capacitance that is can achieve the voltage peak to peak for ripple. Okay. Now this is a VP here, primary, and we can find the V secondary by using the ratio it give. So here we got the VP for secondary is 60 volt. Now we need to center tap by half it with 1/2. So we get 30 volt. Now we can use a KVL to find the V out here. Now here we can find V out is equal to 29.7 volt. Now for the capacitance, we want to find a capacitance that achieve the VRPP. So we put the VRPP is equal to V out over with 2FRLC, and we get C is 206.25 microfarads. Now for the B, draw the waveform for V out. And this is the waveform of the V out. Okay, it want 2 cycle, and this is the voltage ripple peak to peak, and this is the voltage. Okay, for the C saja was method, so the method is increase the capacitor value. Okay, so for the D, it said that V in is equal to V average, IZ max is equal to 8 milliampere, and IZ min is equal to 1.5 milliampere. So determine the range of load resistor RL here. Okay, so here we can find the full average by 5 VP minus 1/2 VRPP. So we get 29.4 volt. So here we must find the IR, IZ, and IL. IZ we already find, so we want to find IR first and IL to get the RL. Okay, so let's go. First we use the KVL and get the IR is 8.7 milliampere. Then we can use a KCL. This is the IR, IZ, and IL. So IR plus with IR is equal to IL plus with IZ. So for here, we want to find the IL max first. So we must use the IZ minimum. So the IZ minimum is 1.5 milliampere. What is given here, right? So we get the IL max is 7.2 milliampere, and for the LL minimum is 0.7 milliampere. So I just paste the information I got just now. So to find the range RL, we just use the V equal to IR. Okay, just a simple formula. So when we want to find the RL minimum, we must use the IL max, because when the RL is minimum, the current will be maximum, right? Will be higher. So we get the RL minimum here is 1.67 kilo ohm, while for the RL maximum, the current will be reduced, right? So the current is IL minimum. So we got RL max is equal to 70.40 kilo ohm. So this is the answer. Okay, that's all from me. Thank you for watching.